Starting. Yeah. Ready? Start.
Let me welcome you again to our group Focus with Humaira, Shrutika, Kushagra and Amay, and myself, Sheetal. So finally, in these 2 weeks, I hope we found our focus through this whole journey. 2 weeks ago, we started with exploring the landscape of our user set, which moved right from, like, it was in the IIT campus itself, which moved from the students to the buggy drivers, to rickshaw drivers, to the stakeholders from IIT or the student affairs representative. And then we moved around to the metro passengers, shared rickshaw drivers in a larger ecosystem. When we got the contextual inquiry from these and moved to the affinity mapping and synthesized all the things that we found, we reached to 5 actionable insights. The first one is availability gives prime confidence. Don't get me mistaken here. This was not the requirement just of the user. This is also a requirement from the driver's side. But irony is, both of them start their day with rejections and negotiations. So both of them want the same thing, but the problem is here. Now, when we look at metro as an option is a beautiful choice. Everybody, all the articles say that, all the users say that. But at the same time, everybody has been vouching that the first flag and the last flag is a problem. Let's look at what GBC says on this. Not just our users, but there have been articles which have been strengthening on this insight. Okay. We've been saying that, okay, transit creates culture. We've been asked, what do you mean by culture? So let's look at this thing that, okay, when a user moves through a specific mode of commute, he forms a specific type of comfort, a specific type of identity, a specific type of familiarity. So user who moves by auto may not be comfortable in a, maybe in a cab, or a user who moves by local is not comfortable in a metro, and so on. So that is what we mean by a identity or a familiarity, and hence the culture. The last thing is about the recurring pattern that a user gets into. So they do this by choice, they explore it, but once the choice is made, it is very difficult to change, or they take some bit of frictions to change. So these were the findings which we got out of Affinity. And then we took it forward to get focus on our user set and then define a primary persona. So primary persona, we got introduced to Samira last time. He is an corporate regular corporate traveler, sorry, a regular corporate office commuter. And her pain points are of a normal commuter who is talking about uncertainty, rejections, predictability, and needs a planned commute, basically. So for her, cost is not a problem, but her hardest thing is to plan her day. On the other side of this is Gupta ji, who's looking for stability and he's ready to work. All that he needs is a visibility to his audience. Now, when we look at the whole business phase, of course, we've understood what our passengers want, what the driver community wants, but at the same time, what Metro wants. Today, has reached its capacity only to 20 to 35% of what they actually want to go. So that is where I guess the Metro requirement is. This also has a lot of backing from the government side, and that's where we are looking at solving the Metro's problem of this last and first mile connectivity. When we were doing this whole study of user set, we found an interesting user set that is corporate office users. They have a specific requirement, and we found that these are the users who would actually look at this first mile, last mile comfort for the first go and would uh, need this experience for their employees. What is the corporate already doing? The corporate is already investing into a travel mode for their employees. The cabs are there, they're running regularly, door to door pickup and everything. So how can we actually get this metro connectivity to reduce the overheads of corporates too? So this was a new angle that we were focusing on, and that's where our business opportunity lies. The original brief. Now, when we look at the original brief was to study IIT at the same time extrapolate it to the metro requirements. This is a huge leap, considering a small ecosystem and then scaling it to a level of a city level planning. That called in for a required variable set, which would be changing when we look at city level ecosystem. Okay. So what are these variables? Of course, the basic variables of driver requirement and user requirement. Now, currently what exists is that there are organic ecosystems formed wherein the drivers and the commuters have unsaid understanding between them on how the route would go, how the passenger would be dropped to their point, etc. Now, what lacks is here is a system that's formed like a rule of jungle. It does not have any predictability. It does not have any rule. There are a lot of frictions, but people have just got used to it. So that is where we felt is our things. Our whole focus was defined by this, and now we define we what we did is we did a first level design and took it for evaluation. So for usability testing, the key questions that we focused on, the one is that do metro travelers understand our service objects? And secondly, are users able to easily understand their end-to-end journey and move confidently towards the booking using our Metro Plus app? So we conducted usability testing with 5 participants. Those were basically frequent metro travelers. And about the task, how we wanted to go about it is that we wanted to test the sorry, we wanted to test starting from the point where they are discovering and getting introduced to our service, and then moving on to booking the entire journey from the app. So we planned on showing different, touch points, maybe let's say on metro tickets, then collaterals, portals, etc. And we just ask users to go through one of these touch points and help us understand what is their understanding of our service. So this is basically our usability testing evaluation, where we have different journey stages. And these are the screens, as I mentioned, that starting from discovery, onboarding, landing, then they come to app, they look at their journey details, payment, and then finally they start their active journey details. And these are the questions that we wanted to answer. So the findings that we got from usability is that, as I mentioned, this is a screen where users have, so we are the user, so this is the screen where users have booked their metro ticket to WhatsApp, and here we are showing our offering. Okay, so in this particular screen, the problem was that the communication was not clear. So here we are only communicating the half part of the user's journey, but users were confused here, and they were not understanding whether the buggy is only for this particular route or is it for their end-to-end journey. So this is one of the issues that we found. So when users move to the app, they can enter their source and destination, and based on that, they can see their journey route. There, they are also given an option to see the cheapest and fastest options. But what happened? 2 out of 5 users missed the offerings on this particular page.
8 minutes done, 7 minutes remaining.
Next, on the same journey detail page, because the users have built this mental model of using Google Maps, they were able to understand the entire journey detail. But here specifically, they mentioned that it is very difficult for them to understand the time and cost for each lap. Because if we see here, the time and cost is not very consistent and scattered across the screen. So it was very difficult for them to kind of see that what is the total time and cost that I would take that would take to reach their destination. And here, this is the metro station point A and point B. But users were not understanding that they have to travel through metro in this particular. So they have to travel from Andheri metro to Dharma Chowk, and they thought that this e-rickshaw will drop them to Dharma Chowk. So that was the confusing point that users mentioned. And as I mentioned, I think that users also said that they are not able to currently the ETA for their estimated time for reaching their destination is missing on the screen, which they can easily see through Google Maps. So these were all the issues that we found through usability testing, and we have fixed it in prototype. So the next screen, Kushagra will walk you.
Thank you, Shratika. So after all these activities, what we found out that route planning and load management, passenger load management is the key to solving this problem. So we aim to solve these with our web and mobile app, a physical pole with a physical device which shows you the arrival time of all the e-vehicles that we have, and as well as it allows you to book your tickets to the metro station, and a fleet of vehicles where route and pole options are based on demand and infrastructure needs. And there is a driver app as well, which we'll be seeing the use later. Moving on, so the types of booking methods that we have, you can use your metro card on the pole itself and an app and a web app for booking any of it. Now, when we were working on the problem, a colleague of mine, a team member asked me, how will we know which pole has high demand for a vehicle? How will the drivers know which route has more passengers and which route to go? So they asked me that, how do we solve this? I said, don't worry about it. They said, oh, you figured it out. I said, no, I'm also not worrying about it. So the vehicles, they have times when they will be making empty runs. That is a real problem. That will result in additional unnecessary cost. So how do we know which pole has how much traffic? Now let's revisit from our previous session, the three body problem, which aimed to solve the sync between passenger pole and e-transport vehicle. A smart system checks the traffic and optimizes the routes for drivers and constant flow for all the e-vehicles for all the passengers. And a small scale server uses algorithms like this Dextra and K-mean algorithm to manage the load balancing. So let's say, for example, if we have a network of all the poles, and each network has a default circular pattern where all the e-vehicles would be moving around. But suddenly, we realize that pole number 10 has unusual heavy traffic and it is asking for help. So what the algorithm does is that it breaks the chain over here, connects the remaining other poles which are coming after that pole to other circulars, routes the vehicle automatically, and there is a constant flow of vehicle back and forth between this node. So the vehicle fills up here, comes back, fills up here, comes back. Doesn't have to go to other stations and saves more time. So over here in this problem, we had one small thing. A smart system checks the traffic. What exactly is that smart system? How does the pole know when to call for help? So human beings are an unpredictable variable. How do we provide them a predictability? Let's consider that you have booked a metro transport end-to-end last mile journey through us, and you're still at your home. You plan to leave in the next 2 minutes, but suddenly the lift breaks down or something other comes up. Now you will be late for your pole, and uh, either our vehicle waits for a long time or the user ends up losing the predictability. So that's where we introduce the concept of half user. A half user is someone who has placed their journey, so they're paid for it, but hasn't taken any action yet on his request. So let's consider a half user is someone who has paid for the journey, but they're 150 meters away from the pole. Okay, the pole is 150 meters away from them. And at the same time, our buggy is still standing at the metro station. It hasn't left the station. And then we get three more half users who are still away from the pole. So in total, we have two users now. So a buggy starts to leave. It is a three-seater buggy, by the way. The moment any one of the user reaches the pole, it becomes a one user, from half user to one user. And the buggy is almost there. And if this user is just 75 meters away, they instantly become a one user. So meanwhile, all the users come together, our buggies are almost reaching there. And if the load is almost full, the buggies keep flowing. So the incentive here is we get a better predictability, we get an efficient vehicle management, and less non-useful trips. So now let's look at visually how we solved it through the prototype. I will just take you through the prototype here.
So, like we mentioned earlier, we were looking at various touch points. We were looking at directly getting to people through the metro app. If any of you who travel by metros have used the Metro One, Mumbai One app, or have done any kind of WhatsApp bookings, it's the easiest way for people to book online tickets. So the best way to reach them where they are is to advertise our service there. And once the user has, let's say this is an example of someone has booked a ticket, a metro ticket from Barul Naka to Vidhan Bhavan. And once they have finished their journey, they see a little pop-up of our service and they can go ahead and explore the app and install it from there. So this is Metro 1, Metro Plus, which kind of takes people through and tells them, how they can plan their journey. The home screen is immediately, it shows you that, okay, you need to put in your destination and it simplifies everything for you. We talk about how they can simply enter their destination. And just in a couple of clicks, we provide them the full planned route. So you'll see there's a breakdown of how much time it's going to take, how much it's going to cost. We're letting them customize how much distance they want to cover. Like, let's say someone wants to go directly from their location to the metro station. We have an option to remove this. We're giving them predictability in terms of cost. We've given them multiple route options. Like, let's say someone doesn't want to take a rickshaw but wants to take a cab instead. So they can just click on the drop down and choose that. We're giving them information about what line they'll be traveling on in the metros. And we're also giving them an ETA, which was missing from our first prototype. We give them a total cost and we tell them if they want to add multiple users, they can. Okay. Once someone confirms their journey and completes the payment, we give them a QR, and this QR can be scanned at every EV that goes to the pole. And because this one single QR covers your first mile, your metro, and your last mile, people don't have to make separate payments, don't have to keep track of separate QRs. It just makes the entire thing seamless. We're also providing them ETA information upfront, and we're giving them a breakdown of each lap in a way that is whatever is current shows you the first thing. Okay. And then from there on, if you take the home screen, you can see the app, your active journey.
We just need one more minute if that's okay.
Look, very fast.
Yeah, so we took our business model and then we took it for further to see the feasibility study whether this business could be run profitably and sustainably. So we looked at it. How big is the market? How big is the market size? So if you look at the total TAM, it's 950 crores. So that is 9.9 lakhs traveler according to Times of India. And the ticket size is approximately 20 rupees one way. So per day revenues come to around 3.8 CR. Next, please. So then we did phase one. So we planned our phase one, our yearly revenue, which would be around 48.5 CR. So these are the 8 lines out of 48 lines that we would be targeting to. So these are based on the number of daily users from those lines. And when we see at the revenues, our ticket revenues are around 46 crores. So we are targeting just 15% of them, which would be our SOM, serviceable, obtainable market. So that's how the calculation would be. And that's revenue come to around 46 CR. Plus we have advertising revenue, which is from buggies. So we would be employing 950 buggies. That will give us 2.5 CR. Next. So this is the cost. So our yearly lease would be 3.9. So total comes to 13.65. So we'll have to pay rent to Metro because we'll be using their premises. Our running cost that includes electricity and maintenance comes to 3.5 CR. Our labor cost, which is the employment for 1,500 people, including the drivers and the other maintenance staff. And for the app development, it would be around 33 lakhs. So if you want, we have all detailed plans. So any questions, more than happy to go last slide. So this is the last slide. So our yearly just operating profit would be 34.85 crores. So that doesn't take into so that is not net profit, but it's an operating profit. So this gives us an indication that this is a very lucrative business model, and we can go ahead with the development of it. Thank you.
Time. Thank you. Okay, the next group is bedroom auto and then photo sharing one. Photo sharing one group is ready? Yeah, okay.